Hello everyone, welcome back. So today I'm going to show you a quick demo how to get your private key from your Geth Keystore with a simple Python script. So as we all know, Geth, the Go Ethereum implementation of Ethereum, stores your Keystore in your blockchain folder if you decide to make one. If not, it's in whatever directory you decide to make your blockchain in. So if we do ls, we see our data 0 folder, so we're gonna cd that, ls, and so we see the Keystore. So we can cd Keystore, and in the lab I do the Keystore one that ends with D2 or 2D, D2 right here. So this is the file path that we want to copy, and we also want to do a quick PWD down here so we get the full path, so we can add this file name onto it after we add a slash after Keystore. But if we go back to the blockchain level, we can see our Python script that we are going to run. It's called the private key decrypt Python. But before we run that, let's take a look at our file. So this is the one I've run in the lab, so this is the one that I have screenshots and evidence for. But this is the one, D2, we can open up in the text editor, which I have open right here. So we import a module from the Geth console we use to initialize the blockchain with, which is right, the list is right here. And I have another demo today with the etash module right here to get miner hash rate and what the miner is going to calculate, such as the threshold and everything else, but that's in the other video. But so we can see we have Web3 right here, it's version 1.0. That's because our implementation of Geth right now is just a little out of date. But if we go back to the code, we can see that Web3 library is right there. And then, so we read the file, we use the decrypt function that's supplied in that module, which is the one that they use in the actual source code itself. But it comes back with an RLPX encoded string. So this doesn't really make sense to us. We can print it out if you want to uncomment line 6, just to see what it looks like. But we're gonna import an ASCII package to then convert it to hex, which is how the addresses are stored. So before we convert it, we're gonna print out this is your Ethereum private key, and we're gonna run it through that function. The reason why we're gonna know their private key is because we know all the public information stored in the Keystore as well as the password. This would not work if you did not know your password. So if you do happen to know your password and you're looking for your private key for some reason, this script will get it from the Keystore. And this is the file in the Keystore itself. So you have your address, your crypto definition. So you have your cipher, the ciphertext, all those parameters. You have your salt and the MAC and the version, everything like that. So it's going to take all of this data. It's going to run it through one of the functions from the W3. It's going to convert it back into an RLPX encoded string. And then we're going to run it through an ASCII library to convert the RLPX encoded string into hexadecimal, so it's easier or more understandable to us. So this is the data that we'll be reading, and we'll be running it through here. So if we go Python 3, it's going to run it through, and we're going to get that as the output. And that has been the output every single time so far. So it's the exact same decryption that the Ethereum source code uses. So this works on paper. I gotta test and retest and make sure this works to make sure that my Wireshark dissector is doing things properly. This is something I was double checking to check with the Wireshark protocol or dissector, and I saw a use case, so I threw it in here, and that's something we have been after for nearly both semesters now. So that's a really nice accomplishment to have, a nice little nugget of information after digging for nearly a year now. And I can't wait for more of these little tidbits of information nuggets of knowledge to come. Thank you very much for watching. Thank you.